At this point, we've covered most of the basics of managing containers individually. We've created groups of containers manually that work together, either by using Docker's rich networking support or using the legacy link functionality. To create these orchestrations of containers, we've been required to issue individual commands ourselves in a specific order. Docker offers another document that can define a group of containers and their relationships. This document is used by Docker Compose, which is another tool in the Docker ecosystem. Docker Compose uses a Docker Compose YAML file that describes multiple containers to manage the containers as a whole. Let's create a very basic Docker Compose file that just runs a single container. There are two different specifications of the Docker Compose YAML file. Version 2 was recently released, and we can use it by simply specifying version 2 at the top of our YAML file. Next, we can add a services section to our YAML, which allows us to define a list of services, or containers, that Docker Compose will manage. Our simple composition will just contain a single container running Redis. Each service in the services section is keyed by the container name. We'll call ours kvstore1. Underneath our service definition, we can specify a number of attributes, most of which are available in the form of options when we use Docker Run directly. For this simple example, we will only specify the Docker image to use, which is simply Redis. Now we can save our Docker Compose YAML file and run it. In the same directory as our Docker Compose YAML file, we can run the command docker compose up, which will start all of the services specified in our file. The output we see looks similar to what it would have had we have just run Redis using Docker Run. Notice on the left of each line in the output, we see kvstore1_1. This indicates the container that the line of output came from. This becomes more useful once we run multiple containers in a single Docker Compose file. Let's stop our container by pressing Ctrl+C. Now, let's add one more container to our Compose file. To add another container to our composition, we can simply add a new name underneath services in our Docker Compose YAML file. For this example, we'll add another Redis container and name it kvstore2. This isn't a terribly useful example, but it illustrates how we can manage two container configurations together. Let's go back to the terminal and run Docker Compose up one more time. This time we should see output for both of our containers. You can now see that Docker Compose started up two Redis instances, and you can see the name of the services on the left, kvstore2 and kvstore1. Let's stop the containers once again using Ctrl+C. Notice that when we run Docker Compose attached, using Ctrl+C sends a sigterm signal to all of the containers. Now, both containers are in a stopped state. We can see them by running docker ps-a. If we run Docker Compose up again, Compose will simply restart the stopped containers. Just like plain old Docker, we can also run Docker Compose with the -d flag, which will run the containers in detached mode. Let's rerun our composition this time in the background. We now just see messaging stating that the containers were started. Similar to the Docker client, we can also stop a composition by issuing the command docker compose stop. We now see a message stating that our containers were stopped. If we want to remove the containers from our system, we can use the command docker compose rm. Docker compose rm will permanently remove the stopped containers from the disk and will prompt you to confirm before doing so. Docker Compose makes managing a group of Docker containers as a single unit very easy.